QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let's have x squared plus 10x plus 25 equals 0. Is this trinomial factorable? Yes or no? And it's yes, this is factorable. And if that would be the case, what are the factors of the given trinomial? The factors are just x plus 5 and x plus 5, or there are 2x plus 5. What are now the roots of this given quadratic equation? The roots, or the root, is negative 5. Did you get 3 over 3? If not, please continue viewing this video. For this given quadratic equation, we are to find its roots. But as you have seen in the previous answers, there's only one root, and a part of the discussion will be shared here later. Now, there are many ways for us to solve for the roots of a given quadratic equation, one of which is the quadratic formula. We will be presenting it soon. And in the previous videos, we used extracting by square roots and by factoring, because we have specific unknown coefficients that will make those steps or processes easier. Here, since this is a complete quadratic trinomial, complete in the sense that it has a coefficient which is 1, it has b coefficient which is 10, and it also has a c coefficient which is 25. So again, it is a complete quadratic trinomial, and for that case we can use in either of these two methods. Number 1, we can use by factoring. The second one is by completing the square. These two are only for a complete quadratic trinomial, and what makes it different is this: we can use factoring if first and foremost this trinomial is factorable, and if it's not factorable, we're going to use the completing the square method. We would know whether this trinomial is factorable or not using AC way or AC method. AC means multiply the a and c coefficients. That's 1 and 25 respectively, so you have 25. This AC now is our basis. We're going to look for pairs of factors that will result to 25. So one of the factors is of course the very well-known 5 and 5. But you could also use 1 and 25. This is positive. You could also take negative 5 and then negative 5 and then negative 1 and negative 25. All of these 4 pairs of factors, when multiplied to their corresponding pair, it will result to 25. The thing here is, if we are going to add these pairs to their corresponding pair, of course, will there be a pair that will result to 10? The answer is yes, and that is this pair here. By looking at this and by deciding that there's already a pair that will satisfy both AC and the coefficient B, this is actually factorable. And with that, we are going to use factoring method. But specifically, a factoring that is not a common monomial factoring, to which we used in solving roots of quadratic equation for quadratics without C coefficient. Factoring here will allow us to resolve to a binomial expression. So I mean 2 binomial expressions. And we're going to use these coefficients here, we're going to pair them to a variable x, as our first term is x squared, so it should be x times x, so x squared. And pair or add those coefficients that will result to 25 when multiplied and 10 when added. That's positive 5 and positive 5. So these are now the factors rather of this given quadratic trinomial. And since we're looking for roots, we are going to make it equal to 0. For this kind of situation, before we proceed, we can see that both factors are just the same. This is because our quadratic trinomial is known to be the perfect square trinomial. It's considered to be a perfect square trinomial because it is a result of a binomial expression multiplied by itself. Just like this, we have 2x plus 5 multiplied to each other. So we can attack this actually in two different methods. I'm just going to use first the zero factor property, okay, because this is what we always or usually do for factoring. And the zero factor or the zero product property tells us that the entire expression is equal to 0 if one or both of the roots or other factors is equal to 0. So both of them are equal to 0. Therefore, the first root is negative 5 and the second root is also negative 5. And this is why earlier we only have one example of the root, since they both have the same value. So our root here is negative 5 with multiplicity of 2, meaning there are two negative 5 here. This is one step in getting the root because we usually do here the zero factor property. Or you could also use the concept of extracting square roots, because if we have here, because one of our answer in our question earlier is this, the square of x plus 5. This is because there are two binomials of x plus 5 multiplied by each other and it's equal to 0. Again, this is by extracting roots. Extracting roots, or specifically square roots, will allow us to take the root of both sides of the equation. Take the root of here, take the square root of here, so you'll have x plus 5 equal to the positive, negative, or 0 of 0. But of course 0 is is a non-negative, non-positive integer, so it stays as it is. And of course we'll have a result here, x is equal to negative 5. As you can see, we have the same roots with regards to factoring or extracting square roots, but these were made possible, both of this, by identifying the concept that this is actually factorable. You could use any of these methods, but generally we only have one root with multiplicity of 2, that's negative 5. So this is how we take the root, or we solve the root of a perfect square trinomial. But this is more importantly how we take or solve the roots of a quadratic expression using factoring that is already given to be factorable. And this is for QuadQuiz! Subscribe now!